Welcome to our session about critical path reduction. In the previous sessions, we constructed the precedence diagram, we calculated the duration of the project, we identified the critical path, but what happens when the project duration is too long? What are the problems and what are the possible solutions? We will look into detail in two solutions, which are activity crashing and fast tracking. So, when the project duration is too long, there may be a lot of issues related to that. We calculated the project duration, how we think the project should be run. But this doesn't always correspond with the ideas of our sponsors or clients. Now, when the project duration is too long, it can lead to different problems like loss of reputation, fines when the duration is exceeded, and of course, extra costs for us and less profit. There are different solutions to reduce the duration of the critical path. First of all, we have activity crashing and activity fast tracking. These are the two solutions that we will look into in more detail. We can change the precedences, but there are also some risks involved. We can reduce the scope in case the sponsor agrees, or we can split the project into phases so that the most important items have been completed before finishing the project and add the remaining work in later phases if it's still necessary. And of course, we can have a look at the triple constraint. Let's look at activity crashing. Activity crashing is reducing the activity duration by adding more resources. Now, we know already that adding more resources cannot be done without limitations. We've seen the crash curve and the crash point already before, and this curve shows the relationship between the number of people working on an activity and the duration of that activity. Once we pass the crash point, adding more people will lead to an increased duration of the activity. It is clear that we have to avoid to add too many people to keep a sufficient efficiency to complete the activity. The effect of activity crashing is a cost increase of the activity. Now we can use the crashing to determine the relationship between project duration and project cost. So when our customer asks us to complete a project within a certain duration, we can identify how much the project will cost for us and offer a price taking into account the requested duration of the project. On the other hand, we can try to reduce the cost and the duration of the project, so we are crashing as long as it leads to a total cost reduction of the project. Let's now have a look at another method to reduce the duration of the critical path, which is activity fast tracking, or simply called fast tracking. Fast tracking relates to doing activities in parallel. The successor task can start before the predecessor task has been completed. We have to calculate in some loss of efficiency because the people doing the work in parallel may interfere with each other. Some examples: when you put in the floor in the room while the painters are still painting the room, may lead to some additional work, and of course some additional precautions to take. You can start on a next task or a next activity while the previous activity is not completely finished yet. For example, you are putting windows in a room and you can start already by painting the windows that have been installed before you actually planned it. So activity fast tracking will give you some additional possibilities to reduce the duration. Let's look at an example at a small project, a project which is composed of making some bicycles. We have a first step which prepares the separate parts for the bicycle. Step 2 is the fast assembly of the bicycle, and step 3 is test and packaging the bicycle for shipment. Let's consider that we are working very fast. We have each step which takes 1 minute per bicycle, and our project is composed of 10 bicycles. So step 1, 10 bicycles to prepare the parts for would be finished in 10 minutes. Then we assemble the bicycles, which also will take 10 minutes. So step 2 will be finished after 20 minutes. And then step 3, there we are finishing, the bicycle is tested and packaged. So the first complete finished bicycle is ready after 21 minutes. And all bicycles are finished after 30 minutes. When we want to reduce this project, we could try crashing. Crashing would mean we put more resources on the different tasks. Let's say we double the resources, people will work faster, the bicycles will be done quicker, and we will go from 30 minutes to 15 minutes. But working faster also increases the risk of failures, of problems, of quality issues. So here we can consider to fast track this project. How we do that? Well, instead of finishing all 10 bicycles before going to the next step, we finish the work in step 1 for 1 bicycle, send it to step 2 where the bicycle will be assembled, and send it immediately to step 3 where the bicycle is tested and packed for shipment. We don't work faster. Every person is still working at the same rhythm, so the quality of the work is assured, but you see that the first bicycle is completed after 3 minutes. And when we continue this sequence, we see that all bicycles are finished after 12 minutes with the same people working at the same speed. Fast tracking offers here a reduction of less than half with almost no extra costs. So fast tracking can help you to reduce the duration of your project in a very efficient way. So we finished critical path reduction. Very interesting items, not so easy, but important for you as a project manager to understand and to apply them when it is necessary. You did a great job. See you in the wrap-up session of this section number 7. Great job.